All right, everyone. I'm glad you're all enjoying your lunch. So we're about to begin our lunchtime keynote. So we are absolutely thrilled to have Chris Levesque, President and CEO of TerraPower, with us today. As many of you know, there's been a whole lot of buzz about the role of nuclear energy. You heard it on our last panel, especially when it comes to meeting the growing energy demands of the data centers and other energy intensive industries. So with nuclear energy gaining ever more traction as part of the solution, Chris is here to share your insights and on this exciting topic as our keynote, the role of nuclear in powering innovation. Please join me in welcoming Chris Levesque to the stage.
Thanks a lot, Mark. Well, thanks so much, Mark, and to the United States Energy Association for having me. And thanks, too, for convening this discussion between experts from the digital world and experts from the energy world. As you might imagine, I work for Bill Gates, who happens to be an expert on both. Of course, he got his start in computing. And in my early days with Bill 10 years ago, we talked mostly about nuclear. But more and more, we're talking about the confluence of nuclear energy and learning about AI terms like inference learning. It's just amazing how these two disciplines are coming together. I did pick up today in many of these discussions. We're also appreciating that they're two worlds that evolve on very different time constants as well. So we have some puzzles to solve here if we're really going to ramp up our energy production the way we need to support AI. I don't think I need to sell nuclear to anyone in this room, really. I think we all understand that we're looking at a tripling of electricity demand between now and 2050, and that's going to vary region to region. You know, it was already driven by electrification, by the shutting down of many coal plants, which make us have to really build up even more. You know, we're big fans of renewables at TerraPower. Bill's invested in, many renewables projects, but we do recognize that renewables are intermittent. And so nuclear is an even better solution on a carbon-free grid. There's study after study that are showing that, an optimum system cost can be achieved by having an emissions-free grid that's 20 to 30% nuclear. So we're all supporters of nuclear in here. I'm going to take that for granted. But one thing we're seeing is that there's some concerns about the capital cost of nuclear. So incredible announcements over the last couple months that have really brought great attention to nuclear and are really tailwinds for us. It's not surprising that those first announcements involve restarts of some nuclear units that were shut down prematurely, really. So that's great. But we do need to recognize those restarts are plants where the CapEx was encountered, many years ago. Those plants were built on the backs of different ratepayers, and they've largely been amortized. So the challenge of getting into new nuclear is really even harder. There'll be a few restarts, there'll be nuclear power plant power uprates, but when you look at the many gigawatts of demand, we're really going to need the new builds for that. So, we really believe TerraPower arguably is the leader here because we're next. We have the only construction license in front of the NRC today for our Kemmerer Unit 1 plant in Wyoming. We have about 1,000 people working on the design project. Our approach is that we're kind of just doing it. There's a lot of things happening around us with great government programs continuing to support nuclear more. We have considerable investment now coming from new sources like the data community. But we at TerraPower have also realized we have risks we have to retire. We need to just get started. And we've been able to do that for a few reasons. And it begins with our great investors like Bill Gates and a Korean company, SK. SK came into our last round at $250 million. HD Hyundai is also an investor of ours, and they're a strategic investor because they're interested not just in a financial return, but they're going to help us scale. They build 200 ships a year, and as Chairman Chung at HD Hyundai told me, in nuclear, you all build things one at a time. You need to let us help you scale. So that's what we're doing with HD Hyundai. So on our team, it begins with strong investors, super strong team of over 600 employees. But really, innovation was how we all got started in nuclear. When Bill created TerraPower 18 years ago, he was new to nuclear. He really thought we were going to need a lot more fission and maybe someday fusion. But he realized it was going to take new technology and innovation. And I have to tell you, when I joined TerraPower and came to work for Bill almost 10 years ago, I was kind of a typical product of today's nuclear industry. Started out as a submarine officer, worked for several large nuclear companies. But when Bill Gates hired me 10 years ago, I really didn't know what innovation was, because I grew up in an industry that really didn't encourage innovation or reward innovation. We encouraged different things. We encouraged performance, repeating lessons learned, making small incremental improvements, but never large leaps. And that's been great for the nuclear industry. It's helped us have super high capacity factors, amazing safety. But if you take that approach for 20, 30, 40 years, you find you haven't embraced much new technology. You've, in fact, avoided new technology in balance with some perceived regulatory risk that you're trying to avoid. So Bill created TerraPower realizing that we had to create a whole new innovative environment for nuclear science. And proof positive on this is not our natrium reactor. Our first big breakthrough in nuclear science actually is in medical isotopes, which when Bill created the company 8 years ago, we never imagined we would be making starting material for cancer drugs, but we're doing that now. We're producing actinium-225 at scale, which is in numerous cancer trials around the world right now. And that's just an illustration of how nuclear was so overdue for innovation. So this first project, again, Chemer Unit 1, which we're conducting in partnership with the Department of Energy and with PacifiCorp, Mark's old company, is ready for construction. We started construction, in fact, on our non-nuclear facilities this June. We had a groundbreaking with Bill Gates and Greg Abel and others from Berkshire. And we're really moving ahead and just doing it, as I mentioned. So construction on our non-nuclear facilities has started. We submitted our construction license to the NRC in March, and I really appreciate the efforts the NRC is making to innovate in their own process. We can really see improvements there that began with Congress asking them to change in the Nuclear Energy Innovation and Modernization Act. And our review process is going quite well. That review process will result in us receiving our nuclear construction permit in 2026. But between now and then, we can work on all of the non-nuclear facilities. And that 1,000-person design team that I mentioned, which includes 300 folks at Bechtel, just over in Reston, is supporting the start of our turbine island and other equipment next year. We're also beginning our procurement process for the large nuclear components and the instrumentation and control system. And that's really important as well. One, to support our schedule, which involves first electricity in 2030 and taking Chemer Unit 1 to commercial operation in 2031. But we also need to show that demand signal to the supply chain. Most of the nuclear supply chain, which is even weaker now following COVID, it was already fairly weak in 2007 era when we thought we'd have a nuclear renaissance. but it's even weaker now. And you're even seeing this with some DoD projects that pull off the same American supply chain. You can see we're even leaner times right now. So for us, it's really important to make those first procurement awards. And as we're selecting and announcing each procurement award, we announced one at an Idaho fabricator called Premier just last week. As we talk to each of those participants in our first reactor, we're talking quickly with them about how do we scale. Because TerraPower's plans involve getting that first unit online in Wyoming in 2030, but quickly ramping up to 5 to 10 units, 5 to 10 natrium units per year as we move through the 2030s. So achieving a lot of milestones. I did want to come back to the technology a little bit and why we chose natrium. Again, Bill realized when he started TerraPower that new nuclear had some challenges with CapEx, and you can even hear the concerns about that now. And his answer to almost every question begins with technology, as it was here. And what our founders saw was that fission was just such a great proven source of energy that's very well valued. But we were seeing that light water reactors, which operate at high pressure, have a lot of inherent costs in them. Because they're at high pressure, they involve needing super heavy forgings that, as we learned in the first nuclear renaissance, there's a supply chain bottleneck for that most of it running through Japan. We realized that high pressure means plants with heavy containment buildings with rebar, this big, and very expensive civil structures. And so our founders realized by moving to an advanced nuclear plant that still uses fission, but instead it cools the plant with liquid metal sodium, we can operate that plant at low pressure. So what we're seeing in the fairly advanced stages of the natrium design now are by moving to low pressure, we have lighter civil structures, far less piping and cabling. We find that we have a plant that will be manufactured almost completely off-site and then will be assembled indoors at our assembly building that we'll construct at each reactor site. And we're seeing a plant that will, on average, be half the cost per gigawatts of today's technology. And the way we do that is simple. We just worked on a technology that had less steel, less concrete, less labor per megawatt generated. And that's important to lower cost, obviously, but it's also important to shorten the schedule, because what we see with the high pressure plants is all of that concrete, all of that steel. When you talk to the constructors, they talk in terms of placement rates. How much concrete can you pour in a day? How much steel you can erect in a day? And so when you choose a plant that has those very high quantities of steel and concrete, that means you have high labor. It means it's going to take longer, and it means you're going to need more people as well. And sadly, that's a problem in the free world as well. Is we have so many folks entering exciting areas like AI. We have less folks who are entering the craft workforce. I serve on Secretary Granholm's Workforce Advisory Board, where this problem is being recognized just as seriously as shortfalls in military recruiting. And the implications for energy security for the U.S. And our national security, honestly, are really just as significant, because if we're going to have energy security, if we're going to have data sovereignty, and we're going to have the power to provide to this data center growth, we're going to need those craft workers as well. So our platform, our natrium platform, it's important to lower those quantities, not just to be cheaper, but it's important that we have a plant that's buildable. If we want to mobilize 5+ construction sites per year, in today's environment, we might not have the craft workers if we don't work on a construction process and a design that can be constructed more easily. So just a little bit more about the technology. One thing which I've learned a lot about, again, in the last 10 years is innovation. I really didn't have the background for it. Natrium was well on its way when I joined TerraPower, but one huge innovation that I was part of just 5 years ago was when we implemented molten salt energy storage into our reactor. So our engineers realized that because our plant operated at roughly the same temperature as the concentrated solar plants that use molten salt energy storage, we realized that we could incorporate molten salt energy storage, which is really a thermal battery, into our reactor. So not only does Natrium then have lower costs because of those lower quantities, but it's a plant that has higher electricity value because we can boost power at Natrium at 10% per minute when electricity is most expensive, and that's when the wind or the sun aren't there. So we've worked on the economics in two ways, by lowering cost and by developing a design that makes higher value electricity. This is being recognized more and more. Tennessee Valley Authority's IRP showed Natrium and showed the very impressive cost characteristics of Natrium as compared to today's nuclear technology. I don't think I mentioned that the plant output is 345 megawatts, but we can ramp to 500 megawatts again at 10% per minute. One important side benefit of incorporating molten salt energy storage, and this is getting a lot of attention at the Nuclear Regulatory Commission right now, is we totally decoupled our turbine island from the nuclear island. And that's going to mean we can build the turbine and all of that equipment completely to non-nuclear standards. And again, that's a development and enhancement over the light water reactor technology. I want to not go too much longer because I would really look forward to your questions, but I do want to talk more about Wyoming and the importance of that project. And even before I tell you how much I love doing this project in Wyoming, I just want to explain something about the project structure. Because some people are probably wondering, with all the concerns about risk and CapEx for new nuclear, how could it be we're working with a regulated utility like Pacific Corp and their subsidiary Rocky Mountain Power on new nuclear? And I'll tell you the deal that we have with them right now. The deal is we had no misunderstandings that we could not start a new nuclear project and put the burden on ratepayers, okay? We watched over the last 10 years other nuclear projects that were stopped, that barely made it to the finish line, et cetera, because those companies were trying to put first-of-a-kind risk and development costs on the back of ratepayers. So when we get these new projects going, I think the best way to think about how they get funded is by thinking about a fair sharing of risk and reward. Who should make the investment? Who gets the dividends? So the way we look at things in Wyoming is those ratepayers should not have anything to do with a first-of-a-kind investment or first-of-a-kind risk exposure, which we've done over and over on nuclear projects and potential nuclear projects. Our deal with Pacific Corp and the people in Wyoming and Utah is that when Natrium makes electricity, they'll pay for the market price of electricity. They won't be subject to any of these first-of-a-kind risks. The two investors who should be subject to first-of-a-kind risks are TerraPower's investors, because our dividend will be large. It'll be over many plants. It'll be a longer payback than probably some public companies could support. But Bill Gates and our other investors totally expect to receive these dividends and to get their money back. Bill has invested $1 billion so far. He did an all-employee meeting with us recently where he reminded all our employees, no pressure, that we were his largest investment ever. And he plans to continue supporting us. So our investors will get their dividend when we sell many Natrium reactors. We also have a great partner in the U.S. Department of Energy. We're building this first plant as part of the Advanced Reactor Demonstration Program, and we've won a $2 billion grant, which is helping us kind of get over some of those speed bumps of the first-of-a-kind nuclear plant. That it's helping fund that 1,000-person design effort, which we won't need to repeat for the second, third, fourth plant. It's helping us pay somewhat higher prices to those first suppliers so they can make their tooling investments and do their shop travelers. These are the speed bumps you have to overcome. And so you might ask yourself, and I get asked this question in Wyoming, which is a very libertarian state. They say, why do you need a $2 billion US grant? And we say, because we're in international competition with China and Russia, who are ahead of us in advanced nuclear technology. And this is really a sovereign investment. It's a national security investment. That's our competition. So the dividend for the US government is renewed leadership in nuclear energy technology, an area where we've fallen behind. The dividend for the US government is reinvigorating the supply chain. So again, with those three sources of money that fund the first plants, for us, it's really valuable to think about who should pay. It should be a fair allocation of risk and reward. And starting with the ratepayers is not the way to think about covering your first-of-a-kind risk. I'll tell you, because we do work in pharma now, it's very clear there. You don't charge the first patient for the hugely expensive pharmaceutical developments, right? You spread that cost. And that's really how we're handling the first-of-a-kind costs on Natrium. It is great to see all of the energy, though, from the data center community. It's clear that in addition to approaches like ours, you're going to see off-takers like the data centers come in who are, and we're talking to many of them, okay? And you might imagine with our ownership, we're very enlightened on these matters. And what we're seeing is, many data center companies are interested in nuclear. They want to see how you're going to get to the nth-of-a-kind cost, though, that we're talking about. So in all these discussions, they want to see the risk get retired, which is what we're showing with licensing progress with the NRC, with getting our first procurement orders out and engaging the supply chain. They want to see those first-of-a-kind risks get addressed, and then they quickly want to have a discussion with us on how we can ramp up to levels like 5 to 10 per year, and how we can get to that nth-of-a-kind cost. So it's a very, very exciting time. Just a little more about Wyoming. We're so glad we picked Wyoming to build our first reactor. It's an energy-producing state. It's a state with a high energy IQ. We're building down the road from a retiring coal plant, and the workers from that coal plant who have many relevant skills. We're still going to have a steam turbine. We're still going to have switchgear, HVAC, all those things. All of those workers are really going to be needed. We'll also take advantage of the grid connection from the coal plant and the cooling water at the coal plant, which are super valuable resources. The support in Wyoming with Governor Gordon, Senator Barrasso, Senator Lummis has been really, really unmatched. And we've been there for 4 years now. And I was so pleased when we broke ground at Kemmerer Unit 1 this summer because it was our first presence in Kemmerer with the construction. And as I told folks then, our presence now will really last a century because it will go through the construction project in 2030. And then just like the coal plant that lasted 60 years, we're going to be there for the rest of the century. I'm going to get to questions in a moment, but again, I don't think I need to sell anyone on nuclear in this room, but there is an urgent need to add capacity, right? And knowing the constraints we have in our supply chain, knowing some of the factors associated with existing technology, we really believe advanced nuclear technology, these lighter, more affordable plants, and moving forward with those projects as quickly as we can are going to be the best path, the fastest path to adding new nuclear capacity.
All right, Chris said he's open to questions. We generally don't we aren't accepting questions. However, you can accept a question or two from me, I think,
All right.
Well, you had talked about multiple plants and multiple locations. So can you talk a little bit about where else in the United States you may be looking at, and particularly for this crowd, a distinction between in the RTO markets or not, and then secondly, internationally, other countries, we know other companies. Can you talk a little bit about that?
Sure, Mark. Next markets, for sure, we plan to go internationally. When Bill created the company, it was for aspirations of solving energy poverty around the world. We really believe in the long term we'll see nuclear energy in many countries where it doesn't exist today, where there's much larger population growth than the US and Europe. So places like sub-Saharan Africa, places like Indonesia. And this, again, is a reason we need advanced nuclear. Today's nuclear plants are very safe. They should be extended to 80, 100 years. But advanced nuclear plants are that next level of safety. Probabilistically, something like 100 times safer if you're looking at terms like core damage frequency and things like this. And I think it's really important to look at situations like you have in Ukraine with the Zaporizhzhia plant there, which is a light water reactor, is often in the news. And it's in the news because light water reactors depend on off-site electricity and off-site water supplies to keep them safe. And so it's a concern when the wartime activities take out the off-site electricity, or you might remember there was sabotage at a dam. So unfortunately, if we think about a more dangerous world in the next 100 years, and we think about expanding nuclear, we need to think about the best nuclear technologies to deal with new, both natural risks like coming from climate change, but also man-made risks, wartime action. And so a Generation 4 reactor like Natrium that doesn't need off-site electricity or off-site water, its cooling is with air by chimneys really around the reactor. Our reactor is below ground. It's going to be a much safer reactor if we want to deploy nuclear around the world. Now that's the long view, zooming way into what's next. We've announced an MOU with Pacific Corp. There's an amazing number of opportunities just in the Mountain West. It's interesting in nuclear, we kind of started nuclear in the South in the US, but the Mountain West is looking like more and more of a hub for this next wave of new nuclear. So there's opportunities there with Pacific Corp, both within, I would say, the existing rate base, but also, as you all know in this room, there's always this balanced discussion of how do we take care of the homes, hospitals, schools, and kind of old industry and the rate base, and how do we accommodate these massive gigawatt additions. We're involved in all those discussions, talking to utilities, merchant and regulated, talking directly to off-takers, also talking to industrial heat users who are really looking at nuclear to decarbonize their operations. That's yet again one of our investors, ArcelorMittal, huge global steel company who also wants to decarbonize their operations. It really starts at Kemmerer Unit 1. I'd see the next units in the Mountain West working with other utilities all over the U.S. Could be regulated, could be merchant. We're talking to both. And then as far as the global expansion, I think Bill Gates said it well last year when he was doing an interview. He said, we have to prove out these new technologies in the rich countries first. We shouldn't try and bring a new technology to Ghana. We should first build it here, license it with the NRC, and then get to those kind of first-of-a-kind nuclear nations. So the path kind of runs through, beginning in the U.S., then countries with existing nuclear programs like, UK, Korea, Japan, France. But then eventually, we'll be out there, answering to nations who need nuclear to grow their economies. And we'll be in competition with China and Russia. And this is yet another reason that the U.S. needs to have an advanced technology to compete with them. I'm telling you, countries that are new to nuclear will want the most advanced technology. Think of telecom. Many nations didn't start with copper infrastructure. They went straight to wireless. So we need to have the most advanced technology if we're going to be competitive globally.
Join me in thanking Chris for your insightful remarks. Thank you, Chris.
Thank you, Mark. Thanks.
We talked about the global leadership on the technology, but it's also interesting to point out, I think, and important to be aware of, is that the United States is the only country, that has a Section 123 in the Atomic Energy Act, which requires the use of U.S. technology to be deployed in other countries, to have those countries enter into an agreement where for non-proliferation, non-weaponization. Now, when we compete against China and Russia in the other countries, those other countries come in and say, well, you don't need to negotiate a 123 agreement with us. You may be signatories to a non-proliferation treaty, international treaty, but we won't impose upon you a 123 agreement, so you can choose to do business with us. That is what companies like Chris Levesque is up against to maintain the global leadership on nuclear energy technology. Just imagine living in a world where we see most of the new nuclear technology is being built by Russians and Chinese, and both countries are certainly capable of designing and building nuclear facilities. So I just wanted to add that sort of as a coda on Chris's remarks about the international development. Thank you, Chris. Okay, well, with that comment.